Let's start with a realization that, well, it's not exactly the kind of thing that helps you sleep at night. We look up at the night sky and we see this vast, sparkling ocean of stars, and our instinct, our human arrogance, really is to think that it's all waiting for us, that it's a stage, a garden. We've spent decades coming up with clever reasons for why we haven't heard from anyone else, calling it a paradox, as if the universe owes us an explanation. But after 50 years of staring at the math of the vacuum, I've come to a much darker conclusion. The universe isn't waiting for life. The universe is actively, fundamentally hostile to the very concept of complexity. When I say we are a mistake, I'm not being poetic, I'm being literal. In a universe governed by the second law of thermodynamics, life is a statistical fluctuation. It's a glitch in the system. And the reason the sky is so empty, the reason there's a terrifying silence out there, is because the universe is finally starting to fix that mistake. Now, look, I know there are people, the technically solvable crowd, who think this is just a matter of time and engineering. They think we just haven't built the right telescopes or the right rockets. But you have to understand something fundamental. The vacuum isn't nothing. It's an energetic, turbulent soup, and the laws that govern that soup are designed to maximize chaos, not order. Life, intelligence, civilization, these are all high-density pockets of information, and information has a cost, a massive, staggering energy cost. To keep a brain running, or a planet running, or a galactic empire running, you have to fight a constant, losing war against entropy. Most civilizations don't fail because of wars or asteroids. They fail because the energy tax of existence becomes higher than the universe is willing to pay. We aren't the main characters of this story. We are a bit of noise in the system that hasn't been smoothed out yet. Think about the sheer scale of the empty. We're talking about billions of light years of absolute freezing void. Why is it so big? Why is it so empty? If the universe were designed for life, it would look a lot different. It would be dense, it would be warm, it would be localized. But instead we have a reality that is 99.999% death. The vacuum is the natural state. We are the unnatural state. And today I want to show you the hard, cold physics of the great silence. I'm going to show you why the laws of quantum mechanics and the geometry of space-time itself act as a cosmic immune system, ensuring that the mistake of life never spreads far enough to matter. It's a terrifying thought, but as a physicist, I've learned that the universe doesn't care about our comfort, it only cares about the math, and the math says we shouldn't be here. To see why we're such a statistical anomaly, we have to look at the initial conditions. This is something we call the entropy of the Big Bang. Now look, if you were to just throw a bunch of energy into a void, you wouldn't expect it to form stars and planets, and people who write poetry, you'd expect a mess, a uniform, boring, lukewarm soup. That is what a natural universe looks like. But our universe started in a state of incredibly low entropy. It was ordered in a way that is so unlikely, so bizarrely precise, that it borders on the impossible. Sir Roger Penrose calculated the odds of this happening by chance, and the number is, well, it's a 1 followed by 10 to the 123rd power of zeros. To put that in perspective, there aren't even that many atoms in the entire observable universe. This is what I mean when I say we are a glitch. We are living in the tail end of a massive cosmic accident. The only reason we have stuff, the only reason we have complexity is because the universe hasn't finished settling yet. It's like a mountain of sand that was stacked in a perfectly vertical column. For a brief, flickering moment, you can have a little colony of ants living on the side of that column, but gravity is always pulling. The sand is always wanting to slide, and the empty we see out there, that's just the places where the sand has already fallen. The silence of the stars isn't a mystery, it's the equilibrium. It's the universe returning to its correct state of maximum disorder. Now the technically solvable crowd will tell you, Lenny, we can just use technology to create our own order. We can build habitats, we can harvest stars, we can keep the flame alive, but they're ignoring the energy bill. Every time you create a little pocket of order, every time you build a computer or a brain, you have to dump a massive amount of heat into the surroundings. You're actually accelerating the decay of the rest of the universe just to keep your tiny light on. It's like trying to stay warm by burning the walls of the house you're standing in. Eventually you run out of wall. The great silence isn't just a lack of communication, it's the realization by every intelligence that eventually arose that the cost of living is too high. The universe doesn't have a great filter that you can just engineer your way through. It has a thermodynamic wall, and that wall is undefeated. Now, let's talk about the expansion. This is where the horror of the math really starts to sink in. Most people think of the expansion of the universe as galaxies just drifting apart like boats on a lake. But that's not what's happening. Space itself is being created. The distance between us and the rest of the cosmos is growing at an accelerating rate. And this is the ultimate cosmic eraser. You see, because of this acceleration, there's a boundary, what we call the cosmological horizon. It's a point beyond which light can never reach us. Not tomorrow, not in a billion years, not ever. Every second, stars and galaxies are slipping over that edge. They are literally vanishing from our reality. If you wait long enough, and on a cosmic scale, it's not even that long. Every single galaxy outside our local group will have disappeared. The night sky will become a black, featureless void. Future civilizations, if there are any, will look out and think they are the only thing in existence. They won't even have the clues we have today to realize there was once a Big Bang. The universe is actively deleting the evidence of its own history. It's cleaning the slate. And this is where the "we are a mistake" part gets really dark. If life were a purpose of the universe, why would the stage be designed to disappear? Why would the laws of physics be set up to ensure that we are eventually inevitably isolated in a cold, dark pocket of nothingness? It's because the expansion isn't an accident. It's the mechanism of equilibrium. It's the universe's way of ensuring that complexity can never infect too much space. The silence isn't a puzzle to be solved. It's a symptom of a universe that is moving toward a state of perfect emptiness. We are living in a tiny temporary window of time where things are still close enough to see. But that window is closing. The mistake of our existence is being surrounded by a vacuum that is expanding just to make sure we stay exactly where we belong, nowhere. But then you have to ask yourself, why is it so big? If the universe is a mistake, why is the scale of that mistake so staggering? We're talking about an observable bubble 93 billion light years across. It feels like an invitation, doesn't it? It feels like room to grow. But in physics, volume isn't an invitation, it's a dilution. Every cubic kilometer of empty space is a cubic kilometer that we have to account for in the energy balance of the vacuum. And this is where we run into the dark energy problem. You see, the vacuum isn't just empty space. It has a weight, it has a cost. We call it the cosmological constant. And for decades, we've had this massive, embarrassing problem in physics where our theory says the energy of the vacuum should be, well, it should be infinite, or at least 10 to the power of 120 times larger than what we actually see. If the vacuum were as energetic as the math suggests it should be, the universe would have ripped itself apart in the first trillionth of a second. No stars, no planets, just a violent expanding soup of nothing. But it didn't. The energy of our vacuum is tuned to a value that is almost zero, but not quite. It's a number so small and so precise that if it were different by even a tiny fraction, we wouldn't be here to talk about it. The technically solvable crowd looks at this and says, see, it's a miracle, the universe was fine-tuned for us. But look, that's not science, that's wishful thinking. In physics, when you see a number that is precisely tuned, it usually means you're looking at a survivor. It means there might be a multiverse out there, an infinite sea of universes where the vacuum energy was too high and they all exploded, or too low and they all collapsed. We are just the mistake that happened to land in the 1 in a trillion pocket where the math didn't immediately delete us. We aren't the goal. We are the statistical residue. The universe is empty because empty is the only version of reality that lasts long enough for anyone to notice it. Now, let's get into the holographic side of this horror story, because this is where the empty starts to feel like a cage. Most of us think that if we want to build a bigger civilization, we just need more room, more planets, more stars, more volume. But in the late 90s, we discovered something about the nature of space that, well, it turned the world upside down. We found that the amount of stuff you can put into a region of space isn't limited by the volume, the 3D space inside. It's limited by the surface area, the 2D boundary surrounding it. Think about that for a second. If you have a room, you'd think the amount of books you can fit in, it depends on how big the room is. But nature says no. Nature says the limit is actually the area of the walls. If you try to pack more information, more matter, more life, more complexity into that room than the walls can encode, the whole thing collapses. It doesn't just get crowded, it turns into a black hole. It's like the universe has a built-in bitrate limit. There's a maximum amount of realness that a region of space can support. And when you look at the vast empty distances between the stars, you realize that the universe isn't just empty by accident. It's empty because the bandwidth of reality is incredibly low. We are a mistake that is trying to run a high-resolution simulation on low-resolution hardware. We want to build these massive, complex societies, but the vacuum literally cannot support the information density. This is why you don't see galactic empires. It's not a lack of warp drives, it's a lack of information capacity. The empty space is the cooling system. It's the buffer that nature requires to keep the few little pockets of complexity like us from crashing the system. The great silence is just the sound of a universe running at its maximum data limit. Every time we try to expand, we're pushing against the holographic bound. We're trying to write more data than the surface area of our cosmic horizon can hold. The universe is empty for a reason. It's because empty is the only way the math stays stable. And this leads us to the Boltzmann brain problem, which is, frankly, it's the most insulting part of the whole story. If we accept that we are a statistical mistake, a low entropy glitch in a high entropy vacuum, then we have to face a very ugly mathematical reality. You see, in a universe that lasts for an incredibly long time, the laws of probability tell us that it is far more likely for a single brain to just poof into existence out of the vacuum fluctuations, fully formed with fake memories, than it is for an entire universe of billions of stars and billions of years of evolution to exist. Think about the math go to get a whole universe. You need that 1 in 10 to the power of a gazillion level of fine-tuning at the Big Bang. But to get just one brain, just one observer to experience a fleeting moment of consciousness before vanishing back into the void. That's much cheaper for the universe to produce. It's a smaller fluctuation, so if you're a betting man and physics is, at its heart, a game of betting, the math suggests that we don't actually exist. It suggests that you are a single, lonely fluctuation in a vast, dead infinity, imagining a history, imagining a planet, and imagining a man named Leonard Susskind telling you that you're a mistake. This is the absurdity of the empty universe. When the technically solvable crowd talks about colonizing the stars, they're assuming the stars are actually there. But the physics of entropy suggests that the most likely state for any observer is total isolation. The empty isn't just out there between the galaxies, the empty is the fundamental reality, and everything we see is just a thin, unlikely crust of stuff that hasn't dissolved yet. We are a mistake that is so statistically improbable that the only way to make the math work is to assume that we aren't seeing the whole picture. The universe is empty because empty as the house always wins. We're just a gambler who had one lucky streak, and the vacuum is waiting for us to go bust. So let's look at the dark forest of the vacuum. I'm not talking about hostile aliens hiding in the shadows. I'm talking about the hostility of the physics itself. If you're one of those people who thinks we can just solve our way into the stars, you have to answer a very simple question. Why hasn't anyone else done it? We've had 13.8 billion years in that time. A single civilization, just one, could have built self-replicating probes and mapped every square inch of this galaxy. It would only take a few million years. On a cosmic scale, that's a weekend. But when we look out, nothing. And the technically solvable crowd says, oh, they're just quiet or they're too advanced for us to see. But that's ignoring the thermodynamic signature. If you have a massive star-spanning civilization, you're using energy, a lot of it. And when you use energy, you produce waste heat. It's a law of nature. You can't hide it. We should be seeing infrared glows all over the place. We should be seeing stars being dimmed by giant structures, but the sky is cold. It's devastatingly cold. This suggests that the filter isn't a single event. It's a constant leak. You see, complexity is leaky. Every time you try to build a bridge between the stars, you lose information to the vacuum. You have to fight the radiation, the expansion, and the raw distance. By the time you've spent the energy to move a single person to the next star system, you've exhausted the resources of an entire planet. The empty is a barrier made of pure economics. The universe isn't a garden, it's a desert where the oases are so far apart that you die of thirst before you can even see the next one. We are a mistake that is pinned to a single rock by the sheer cost of travel. The terrifying truth is that the universe doesn't have to kill us, it just has to wait for us to run out of batteries. The great silence is the sound of a billion civilizations realizing they can't afford the trip. Then there's the quantum decay of purpose. In our world, we think that if we do something, if we build a monument or write a book, that information stays real. But in the quantum world, there's a process called decoherence. It's the way a quantum system leaks its information into the environment until it becomes just part of the background noise. On a large enough scale, this is exactly what happens to a civilization. We are a mistake that is slowly being blurred out. Think about the signals we send into space, our radio waves, our TV shows, our hello to the cosmos. As those waves travel, they don't just keep going forever. They hit the vacuum fluctuations. They get stretched by expansion. They get distorted by the dust of the interstellar medium. By the time our most powerful signal reaches the next galaxy, it's indistinguishable from the static of the Big Bang itself. The universe has a garbage disposal for information. It doesn't want to remember us. This is the ultimate answer to why the universe is empty. It's not that the other civilizations are gone, it's that their information signature has already been dissolved. We are looking for footprints in a sandstorm. The technically solvable mindset assumes that the universe is a stable archive, but the physics tells us it's a shredder. Every star we see is a countdown, every light we look at is a flicker that is already on its way to being erased. We feel terrified by the silence because we think it's a choice. But it's actually a physical inevitability. The universe is empty because remembering is too much work. It's much easier for the vacuum to just let us fade back into the static. We are a signal that has already peaked, and the rest of the journey is just a long, quiet descent into nothing. And then we reach the simulation barrier. This is where the physics of the empty starts to look less like a natural disaster and more like a design choice. If we are a mistake, we have to ask who or what is observing the error. You see, there's a concept in quantum mechanics called the quantum Zeno effect. It's the idea that a system doesn't change as long as it's being constantly observed. But the moment the observation stops, the system collapses or evolves. When we look out at the universe and see nothing but empty, we are seeing a system that has been allowed to evolve to its most boring, stable state. It's as if the observer, whatever or whoever it was, has looked away. We are the leftovers of a process that finished a long time ago. The technically solvable crowd thinks we can reignite the universe, but you can't wake up a house that's already been abandoned. The void is empty because the attention that once held the complexity together has moved on. We are the mold growing in the corner of an empty room. This leads to a chilling realization about the nature of our mistake. If we are a glitch in a simulation, or even just a fluke in a natural vacuum, the empty serves as a firewall. It's there to make sure that the glitch doesn't spread. Think about it. If you were running a program and a piece of code started replicating out of control, you'd isolate it, you'd put it in a sandbox. The 93 billion light years of void, that's the sandbox, the speed of light limit, that's the clock speed of the processor. We are trapped in a terrifyingly large cage precisely because we are a mistake that the universe cannot allow to escape. The silence isn't because no one is there. It's because the firewall is working perfectly. We are shouting into a vacuum that was designed to swallow our voices before they can infect the rest of the code. So where does that leave us? If the math is right and the vacuum is a firewall, and we are just a glitch in the thermodynamic ledger, what's the point? It's a question that makes a lot of people angry. They say, Lenny, if we're a mistake, then nothing matters. But I think they're looking at it from the wrong end of the telescope. You see, in a universe that is fundamentally designed to be empty, the fact that we exist at all, even for a flickering moment in a dusty corner of a minor galaxy, is the most defiant act in the history of physics. The technically solvable crowd wants to believe we are the masters of the universe. They want to believe we can conquer the stars and rewrite the laws of entropy, but there's a much deeper, much more profound beauty in being a mistake. If we weren't supposed to be here, if the universe is actively trying to erase us with expansion, radiation, and time, then every second we spend alive, every thought we have, every piece of art we create is a victory against the infinite. We are the noise that refused to be quiet. We are the information that fought back against the shredder. The terrifying truth isn't that the universe is empty. The terrifying truth is that we are the only ones who care that it's empty. The vacuum doesn't feel lonely. The stars don't feel silent. Only we do. And that feeling, that awareness of the void, is the very thing that proves we are more than just a calculation. We are the universe's only way of looking at itself and saying, this doesn't make sense. We are the error message that gained consciousness. And maybe, just maybe, that's enough. We don't need to colonize the galaxy to be significant. We are significant because against every law of probability, against every iron rule of thermodynamics, we are here to witness the empty. So the next time you look up at that black, silent sky, don't feel small, don't feel like a victim of the math, feel like a rebel, because in a universe of perfect, boring nothing, you are the most interesting something that ever happened. The mistake isn't our failure to reach the stars. The mistake is the only thing that gives the universe a reason to exist in the first place. We are the glitch that changed everything. This is Leonard Susskind. Thanks for being a part of the error and for listening.